What's up, folks? I'm back. This week we are going to try implementing none other than Schmidhuber's problem set papers work that have been released over the span of since 1989 to 2025. So this is following up from last weekend's implementations with Yarrow, where we tried to do something similar for Geoffrey Hinton, and we were able to successfully do these implementation over the span of 30 hours. There is like a whole report that you can look up, and there's also a website that explains the walkthrough, that explains how we got here in terms of the agentic coding, agent-driven programming behind it. For our experiment here, we are using Claude Code and Opus 4.7. So, okay, so how are we going to start? Well, first thing is that we have this repository that contains the problem sets. You can think of them that way. You can think of them as a reference to implementations that we will task the agent to work on. And so, for example, if I go into here, as you can see, there is nothing here other than a little problem placeholder file and some README. So what we are going to do is that we are going to try to build up a little local context within the agent by describing what we are going to do, providing the references, and then we are going to create a spec. And then after that, we are going to create waves, and each wave is a set of agents that can solve or implement a category of these problems that are relevant that can be tied together. The current toolkit that we have are actually very simple. I have Claude. The team mode is the feature that I use the most. This is the feature called Team of Agents. Team of Agents right here. As you can see, it explains how it works. So we are going to explicitly ask the agent to do that. So that's one of the things that I have enabled. The second thing is the GitHub CLI. It is really important to have your GitHub connected from your local environment to the repository that you're trying to write to, read from, or reference. In this case, I am a contributor or collaborator on the Cybertron AI. So because of that, my GitHub CLI also will be able to have access to that. That's the second thing. The third thing is the task list. Basically, we are going to come up with it, or the context building. So I'm going to start out doing that. Okay. So first thing, I will get the agent. So I'm starting this out explicitly or specifically inside Sutro Yarrow, which is this little environment. It's like a repository, but it's a code base, but it is designed like a kind of lab that connects to your Claude Code. As you can see, when I open it, it tells me when was the last update, what went down, what do I need to synchronize, what do I need to do, and whatnot. So I'm going to do that. I'm going to ask the agent to do these updates for us. And then after that, we're going to task the agent to look at the Schmidhuber repository, and then from this repo, try to come up with a task list. Okay, so I'm going to do that. Can you check the Telegram channel to the latest and also the Google Docs? It looks like that Yaroslav and the Sutro team had a meeting on Monday, and we have a new set of tasks. So let's update the local context via the connectors, and also let's update the hook that's on the startup because it seems to be outdated. Okay, let's see. So what it is going to do, it is going to first pull in everything that we have. So I have this chat. Yeah, this is one of the channels where we do a lot of back and forth. And then there are a few other channels, obviously, related to Sutro. So in this Sutro Yarrow code base, one of the skills is called Sutro Sync. And in this sync skill, it knows how to use the Google synchronizer, which is a script we wrote. And since the Google Docs are open, you can easily parse it. The second thing is obviously the Telegram. The third thing is looking at what else is going on inside the repo. So it will probably come back saying, oh, hey, there are some new PRs or something like that's going on. But after that, I will immediately get the agent to start focusing on the problem set that we're looking for. Okay, so I'm specifically interested in Yaroslav pointing out that we potentially should try implementing Schmidhuber et al.'s problems, and the repository, I have cloned it locally. I'm going to provide you the URL, but you can also find it. You can also find it in the Cybertron GitHub repo organization. The task that we have here is to do the same set of work that we did with Hinton's problems. And if you recall, I'm going to provide you the ID for the session that we used to do this work. I'm copying the ID here. The main set of tasks ideally would be creating a spec, but first you have to go through Schmidhuber repository, see if there's an implementation. If not, then you can use the Geoffrey Hinton one as an example. And then after we create a spec, we put up a GitHub issue, and then we will look through how we can use the team of agents that will allow us to these implementation over the span of next 20 to 30 hours. So it's very loose. I don't really use a specific language. I'm not using like anything technical. It is somewhat, okay, so, oh, this is interesting. So it found, without me describing that, it did find, so it did the fix, Telegram, chat yet updated, Google Docs, what surfaced from Monday's meeting. So I have not caught up with the meeting. I'm obviously not there. I'm doing this remotely. Ross, your Hinton problems demo, looks like I was mentioned. Anastasius, Sutro Anna, auto research loop, not formal, no formal homework. So this is referencing because previously we used to have weekly kind of challenges and homeworks. This week is kind of, the directions are changing, but Yaroslav's directives this week from Chat Yaroslav are general. Yaroslav set up stops and wants you to fire off. So it knows who I am because of the identity. This is something that is in the Sutro Yarrow. When you open up the repository, it tries to sync your name, your Telegram, and the Google Docs. So that way, if you're mentioned, it knows it's you. He flagged 3 things from your Hinton problems. Run helped. Okay. There's a metric for that. Okay. So I think that's good. I'm gonna go ahead. So he's gonna want me to start, look at that. So it kind of already knows that that is what we are going to do. But just to be on the safe side, I'm going to copy this thing. Don't worry about the skill crap. That's because I have a lot of skills, and one of the issues that to this day that Claude Code and most other coding agents deal with is that skill is like a little retrieval thing. So if you mention a word like a multiple agent, the actual skill thinks you're referencing that, but I don't want that. What I want to happen is Claude Code to fire off this mechanism, and you will see it in a second. What happens is that it will split off the screen because I have installed the iTerm controller. So Claude Code will split up the terminal, and it will create a team of agents in front of you, and it will start doing those tasks. But before that, I want to really confirm that it is going to create a spec as a GitHub issue so we can reuse for all the problem sets. So while that's happening, one of the things that was interesting, okay, so there we go. It created the task list. So this is Sutro after dark. Usually the Opus is slower. We're not in peak hours. I don't know what's, the fast model is only for 4.6, which is not really what I'm looking for. Well, it's kind of interesting. It already started creating a main agent. So I don't mind this. I mean, this. So previously we ended up being able to do all the hinted implementations sub 800,000 tokens in Opus 4.7 with a couple of errors from here and there. I don't think I have time, but if I had time, I would actually try to create a few toolkit that would reduce the bash calls. Last week I briefly touched on this when I demoed the task list, the way the agent went about it. So if you end up going to build notes, there is some stats, and so now I'm actually doing this a version of this video from the beginning, but last time I wasn't sure. It was the first time experimentation. I did it, and then post when it got completed, I implemented it. So this is what we want to trigger. This is the little mechanism that called team of agents that Claude Code offers, and this is what I was just referencing. So initially I was thinking about improving this, but that's fine. We're just going to try to see if we can replicate it one more time, and if we do so, then we will go ahead and try to optimize things to avoid early optimization. Okay, so let's see. Is this creating a GitHub issue? No. So I have verbose enabled with Claude Code because it's really helpful for you to read what's going on. Just like seeing this immediately tells me, oh, you know what, there might be a better way to fix this. There might be something that I can do, or it is doing a task wrong. So having the verbose enabled is actually really helpful. Okay, so it's a strong context. Let me look at one fully implemented Hinton stop to confirm the canonical layout and draft the spec. Okay, that's good. This is getting a lot closer to what I'm looking for. So anytime we should be expecting a new issue opening up here. Now, the interesting thing here is that when you have the repository, that repo, that Sutro Yarrow, it already contains a lot of information. So it doesn't get lost. Like even when it gets lost, it is able to look up. It is able to look up like all these previous notes and conversations and like the history of the chat. And so there's like a full website. This is all the previous sessions, experiments, all the meetings. This all gets parsed and documented by the Claude Code agent. So that's what that repository is. Basically, that repository kind of creates that, sets that environment up. Okay. So it created the spec locally. What I'm proposing, inventory, 58 stops in Schmidhuber, all not implemented, catalog grouped by year, spec contract. Well, what I want to do is now I want to make sure that the agent understands. Okay, so this is what happened. This is what happens when you give it like some open-ended problems. It walks the agent, the Claude Code agent tries to reduce the scope, or rather try to come up with a planning. So let's say, wait, what is going on? Let me understand what's going on. All 8 in V1, defer the RL. Let's see. No, that's fine. I think I will go. Okay, so this is interesting. It's kind of making me worried because it considers Vizdoom on Torx to blow up agent budget. Okay, you know what? That's fine. That's fine. I'll just go with this one for now. By year era recommended, by difficulty, by optimizer family. So I think I would go by optimizer family. I would say so. Yeah, see, matches the Spec's algorithmic faithfulness rule that breaks chronological coherence. That's totally fine. I think I would rather go with that. And the reason that is just because you will see what ends up happening per each wave. There are like these specialty agents, and what that really means is that it creates like a spec for how the sub agent or the team of agent to function. So I'm just going to go with that. Okay, should the spec also explicitly mark stubs are likely to fail to reproduce citation gap before the run starts, all that agents cover and flag them. No, I think we want to flag them. Okay, so that's good. So this is an improvement because previously, as I mentioned, the 800,000 token thing, that was because parts of that wizard never ended up happening. So a couple of times when I started out, I had to kind of stop the agent when I was reading through the trail of the way it was going to do the implementation. And they were like, no, that you're getting too excited. And that's the thing. That's usually either the agent is overly eager to do implementation, or it tries to over engineer by literally walks you through a survey, and the survey is just like, I've gone through like 15, 16 question surveys. So and this is not like feedback survey, just the agent tries to extract the spec. And then sometimes they're like, oh, this is interesting. I did not even think about including that in the original design. But sometimes just like you're too much out there, doing too much. You got to stop. Okay. But this is interesting. I need to actually look at this. I forgot. Guess Mr. Schmidhuber. Okay, spec draft. Okay, so we have the drafts updated, optimizer. Okay, propose wave plan and team create dispatch. So team create is the internal call. It's a tool call. Review spec. Myself, file spec as a design agent team, file spec, ping Yaroslav, input before. Review spec, make sure we open up a GitHub issue using your agent observer signature. And then if it makes sense, then let's design the agent team and start dispatching the different waves. Keep in mind of the criteria of not using other than NumPy if that is still a condition, given how Yaroslav have defined the problem set. Let's see if it finds that. So the reason this is because we have another harness slash bench that tries to come up with these solvers. I call them solvers, whatever you want to call them. It basically new ways that you can learn the problem. It's not optimization. That's the whole, that's the whole point. So I have been focusing very much on the SAT solvers. That's why I call them that, because I'm still trying to explore various areas of program synthesis and verification. But there are a lot of other methodologies. One of them is the Gaussian, the GF is the other winning methodology. Okay, let's see what's going on. Good catch on NumPy-Only constraint. Let me verify. So there we go. So that could have been, that could have dramatically, that would have caused a lot of problem to do 10 implementation in parallel using Torch or something like that. Live repo matches local, no existing issues. Let me tighten the spec. See, it actually missed that detail. I did not say check the repo for issues. I said create the spec as an issue. So let's see. All right, so it tries to preview filing this. Okay, there we go. So this is what you want. This is why having the GitHub CLI available, or any other CLI really, it would make the agent be able to do these explorations. Okay, so this is cool. We're here. Spec minimum, pure NumPy, dependencies, explicitly disallowed, or what? So disallowed, Torch, Gymnasium. Okay, all right. So we have an RLM. Maybe that is something that we can later integrate. Wave plan. Okay, so that's cool. It contains the plan here. All right, let's see what's going on. So there's a couple of other things now I want to point out. Keep in mind that we want a PR per each wave, and we want the last agent doing an audit and review and posting that audit and review to the PR of each wave, and then only then the next wave can dispatch. Oh, there we go. It actually, that's, so I guess I don't need to, yeah, I don't need to. That's very cool. I didn't even need to say that detail. It knew from the reference of the previous session that is the mechanism I have introduced, how it should go forward. Show me the exact teammate prompt first. Nah, I don't really need that. I fire wave 1 and 2 and in parallel. So I'm going to, well, I don't know why it's not saying in parallel. So let's see. I don't know what wave 0 is. So let's see. Okay, no, it is creating a work tree. It is doing it in parallel. So the way Claude Code does it, it uses the file system and it creates, oh, there we go. So that's what I was just referencing a minute ago. So now the Claude Code, the actual input, it turns into a Tmux session, and then it controls iTerm. So this is iTerm, and it will create, you'll see what will happen. It will open up a bunch of other windows, and each one of them are connected to the main agent by observing the Tmux session. And then at any point, if you want, from the main one, you can send a command or a message to the sub Tmux session. Now not today, but a different day, I will show you folks a terminal that I'm designing. And the way it works is that it turns each of those sub Tmux sessions into a window that you can actually chat with. Okay, cool. There we go. So that's what it looks like. It splits the window. That's the team lead. I'm going to open this up to make space. All right, there we go. So that is the beginning of the experiment. We'll see how the next 20 to 30 hours will look like. We'll report back. Oh, and then in the background, this is the other thing that you're not seeing, but I have a hook. There's a very simple script that I have in all my Claude Code sessions, which is that when it hits the bandwidth before the 5-hour limit, which looks like today as of May 6th, that might change, but it will. So that's how my budgeting system works. That's how I avoid $300 bill accidentally showing up. But yeah, we'll see when this completes. I will do a write-up and come back, do a review. All right, peace, bye.